We're now going to turn our attention to a key blocking operator defined in RxJava's single class. This operator will block the calling thread awaiting for a single to emit its value. And the operator we're going to talk about here is the blockingGet operator. Note that the single that emits a value is typically running asynchronously in a different thread of control than the thread that's calling blockingGet on the single. So as the name suggests, blockingGet can be used to block the calling thread until the current single signals a success value or throws an exception. If all goes well and no exceptions are thrown, then the value that's emitted by the single is returned to the caller. Otherwise, if the source signals any errors, the original exception will be thrown. And note that any checked exceptions will be wrapped up in a runtime exception, which makes the exception handling easier to program. Interestingly enough, there's no timed version of blockingGet. So it's essentially an all or nothing proposition. You either wait for the blockingGet to complete successfully or until an exception is thrown. Internally, blockingGet uses RxJava's subscribe operator, defined on single, to initiate the single processing chain. If you take a look at the source code at the bottom of this slide, you'll find the source code for blockingGet, which is part of the single class. And you'll see that what the source code does is it first creates something called a blocking multi-observer, stores it as a local variable. It then makes the subscribe operator call on that observer, and then it returns the observer blockingGet call, which is kind of a nested call that will block until all the processing is done. So you can see how subscribe is used to initiate the processing, as is typically the case with RxJava and other reactive streams implementations. This operator doesn't operate by default on any particular scheduler, so you can designate where you want it to run by using other methods like subscribe on and so on. However, the single that emits a value most often will run asynchronously in a different thread of control. You don't want to use this particular operator very much. It should be used sparingly and only if you really need to have a value before your program continues. Here's a very simple example that we'll talk about more when we get to the case study at the end of this lesson, where we have single from callable, which is a factory method operator that's going to make a call. Call, of course, is a callable. And then we're going to go ahead and have this subscribe to run in the scheduler's single thread, so it'll run in a background thread. But then the calling thread will invoke blockingGet, which will block that calling thread until the background operation running in the single background thread completes. And when that's all done, we go ahead and print the results as a mixed string. Project Reactor has a mono block optional operator that behaves very similar to blockingGet, in the sense that it blocks indefinitely until the next signal occurs or until the mono completes empty. The main difference is if the mono completes empty, what comes back is an optional that's got no value in it, whereas if it completes successfully, you get an optional that has a value. In contrast, blockingGet just returns the value, and if something doesn't come back, you'll either get an exception or you might get a null back. So using block optional eliminates the need to have to deal with null checks. Both these methods are very similar to the join method that's defined in Java completable future. You can see here how you could do an asynchronous computation in the background to multiply two big fractions together using completable futures supply async factory method, which runs things in the background. And then you could go ahead and take the future that came back from that and call join on it, which would have the calling thread block until the background computation was finished. So very, very similar to the way that blockingGet and block optional work in reactive streams frameworks.